Hello. Now we're going to find slope when you're dealing with decimals and fractions in the points. Okay, now what we have is a simple rule on what to do. And one of the things that you're allowed to do with any 2 points, and it won't change the slope, is you're allowed to multiply each element in the point, that means each x and y that's in there, by the same number. Alright, now before we actually do that, I've got 2 different points up here I want to demonstrate with. I want to show you something. So, if we're going to find the slope of the first one, we've got m equals, and I'm going to put my little thing up there, y2 minus y1. So I'm going to put in -3 minus 5, x2 minus x1. 2 minus 3. So let's calculate that really quick. -3 minus 5, that's -8. 2 minus 3 is -1. -8 divided by -1 is 8, isn't it? Now let's do it with the second set of points. So now I have my m equals y2 minus y1 again, so -9 minus 15, x2 minus x1, 6 minus 9. All right, let's do our calculations. -9 minus 15, that's -24. 6 minus 9, that's -3. What's -24 divided by -3? It's +8. These 2 sets of points have the same slope. But let's examine them now really quick. Let's examine 3, 5, and 2, -3. And let's examine the second set, 9, 15, and 6, -9. 3, 9, 5, 15, 2, 6. -3, -9. I hope you're looking at it and you're saying, hey, I could take each one of these and multiply by 3 and get each one of these. Now this is not a formal proof. It's just meant to be a demonstration to show you that, hey, if you multiply each element, each x and each y, by the same number, when you calculate the slope, it will end up being the same. Now you might be saying, okay, great, big deal. How does that help me? Because it wasn't hard to figure out either of these slopes. Let's take a look at this next problem over here with decimals. It's not any fun dealing with decimals. And when you have them in points, they can give us some pretty ugly numbers with decimals on the top and decimals on the bottom. But hey, there's a very simple way to get rid of decimals. We could multiply each of these by 10. When you multiply by 10, this is something they actually taught you back in about 6th grade. When you multiply by 10, all decimals move 1 place to the right. So the new point would be 37, 45, and 25, 31. Those are nice whole numbers. That's not a big deal. Now it's m equals, I'll put my little starter out there, y2 minus y1, 31 minus 45, and then x2 minus x1, 25 minus 37. 31 and -45, when you put them together, that's -14. And 25 and -37, when you put them together, that's -12. A negative divided by a negative is a positive. 14 over 12. It's an improper fraction, that's okay, but this also can be simplified. You can divide a 2 out of the top and out of the bottom, and you should end up getting 7 over 6 there. Now let's look at the second one. It's got a dreaded fraction. but we can still use the same property. You can multiply each element by the same number. All right, now I picked a relatively simple one here. This is 4.5. All right, it's the only one that has a fraction. Now, if you had more than one fraction, you're going to have to find the least common multiple of the denominator. So let's say this was 6 1/3. Well, the least common multiple of 2 and 3 would be 6. But since this is the only one, 4.5, we can multiply everything in these by 2. What's 4.5 times 2? Well, I'll just visualize it. 4.5 plus 4.5. I hope you come up with 9. So we get 9, 2, and up 9, 4, multiply everything times 2, and negative 12, 8. From here, it's the nice straightforward step of just plunking it into our formula. So y2 minus y1, 8 minus 4, and then x2 minus x1, negative 12 minus 9. 8 minus 4 is 4, and negative 12 and negative 9 is negative 21. Now, students will say, Mr. Trapp, should I leave the negative on the bottom, or should I move it to the top, or whatever? It's not incorrect on the bottom, but if the answer is negative, we usually just write it out front. So it'll become 4 over 21 with the negative right there. And you actually can, that negative could be on the top or the bottom. It's the same thing mathematically. Anyway, take your time when you're doing these. Just remember, if you've got a decimal, you're allowed to multiply each element by the same number and you won't change the slope, but you can make your arithmetic a whole lot easier to deal with and work through. Good luck.